Buongiorno a tutti.
Good morning and welcome to this meeting on scientific topics. The title of this meeting is From the Universe to Life, an inevitable pathway or a singular event. With this meeting, our intention is to dwell upon some aspects that are related to the genesis of life that have already been touched upon during this edition of the meeting, during the exoplanet session that has been organized by Euresis for the development of scientific culture and the CEO Foundation. For those of you who have already visited that area, you have probably already had the chance to see that recent discoveries have highlighted new connections between our own existence and the space. To a certain extent, even reducing the distance between us and the space. So, thousands of extrasolar planets have been discovered, and this has highlighted the fact that the existence of planetary planets goes hand in hand with the presence of so many stars, and therefore that there must be also so many planets. At the same time, evidence is there on the fact that there are molecules based on carbon, the so-called organic chemical molecules, and this on asteroids, on comets, and in space in general. So the planet that we inhabit and the molecules that we are composed of appear today to be in continuity with the structure of space compared to some year ago. To a certain extent, space appears to be very complex with the formation of planets and also with the synthesis of complex molecules. Our planet is certainly a very peculiar planet, but actually the biomolecules are very complex ones. But they can be seen as combinations of simpler molecular fragments that are available at a cosmic level. This evidence has stimulated us to organize this kind of encounter. New discoveries have basically highlighted an eternal question, that is to say, where do we come from? And this in the light of a new awareness. We are basically between two paradigms. We are between two opposites. The specificity of the Earth and the complexity of the molecules that we're composed of may be such that they have been created in cosmos just once, and this can be a fact. And therefore, the immense number of planets and the presence of carbon-based molecules can be seen as a very large number of attempts in which just one example of success has taken place. This is quite amazing. Sometimes it can be also scary, but also very interesting. And then there is an opposite view that we might turn out to that we might consider from the prerequisites that our cosmos, our universe, has developed following the laws of physics, constantly increasing its complexity until life was created. So we may have to deal with a cosmos that, because of its very nature, tends to life. This is also quite astonishing. The idea is that of a universe whose natural evolution coincides of life. So this is also quite scary to a certain extent. And these kind of visions are indeed puzzling. Arthur Clarke, cited by Stanley Kubrick, actually the two collaborated to a famous film, a famous movie of 2001, once said that there are only two possibilities. Either we are alone in the universe or we aren't, and both of them are very scary or equally fascinating. We wanted to go into the details of this topic, and in order to do that, we invited two exceptional guests, two renowned personalities. They will approach these aspects from different viewpoints and with different approaches. We have Antonio Lazcano, professor at the School of Sciences of the University of Mexico. He is a biologist, and we thank him very much for being with us today. He was born and was raised in Mexico. He studied at the National Autonomous University of Mexico City, and currently he chairs a research group on the study of the first evolution of life. Antonio is a reference personality worldwide on the genesis of life. He is the author of a number of publications and papers. Some books are scientific popularization books. One of them is a world bestseller and sold a lot of copies, about 800,000 copies, and it was The Origin of Life. He's always been involved in these issues ever since the beginning of his career, and because of that, he's had very important personalities with the founding fathers in this sector, specifically with the Russian scientist Alexander Opahin. Actually, he says that he remembers him as the Russian grandfather. And also with Stanley Miller, the American scholar, who is the author of an important publication that on spontaneous synthesis of carbon-based compounds. So he published a number of publications with Stanley Miller. And he also collaborated with Francis Crick, who dealt with the origin of life for a period in his life. Lazcano's contributions are on chemistry and the study of formations that allow for the genesis of molecules and compounds. Antonio was twice the president of the International Foundation for the Genesis of Life, and he was member of many advisory boards on these topics, including advisory boards within NASA and NATO. He received a number of laurea honoris causa also from the Milan University. In 2014, he was appointed as member of the National Council, which is the most prestigious scientific board in Mexico. So thank you very much, Professor Lazcano, for joining us. Together with us next to me, we also have Don Giuseppe Tanzella-Nitti, a professor of fundamental theology at the University of Santa Croce, Università della Santa Croce. Don Giuseppe Tanzella-Nitti graduated in astronomy at the University of Bologna. For some years, he dealt with radio astronomy and cosmology as a researcher at the National Research Center in Bologna, and then at the Astronomic Observatory in Turin. He is the co-author of the first general catalogue of on galaxy speeds, and in 1997 he was made a priest, and in 1971 doctor in theology, and currently he is ordinary professor of theology, of fundamental theology at Pontifical Università della Santa Croce in Rome. As a theologist, he studies the relations between contemporary culture and Christian religion. He published a number of essays and publications on the relationship between theology and philosophy, and on the unity of knowledge and the humanistic dimensions of scientific research. He is the editor of the Interdisciplinary Dictionary Between Science and Faith, and the author of 4 volumes on theology, on the relation between theology and science, to be completed. He chairs the research center at the between science and research at the Pontificia Università della Santa Croce in Rome. And he's one of the organizers of the permanent seminar for Italian and foreign researchers to complete their scientific training within the context of humanistic studies. Thank you very much, Don Tanzella-Nitti, for being with us. When preparing for this event, we decided that I'm going to pose a general question to the two speakers and then a more personal one. And I have a first question to Antonio Lazcano. I would like to ask him what is the current knowledge when it comes to the origin of life on Earth, and what data can be relied upon and what data can only be assumed. The first thing I would like to say is that I do not speak very much Italian. My Italian is some kind of a mixture between, so to say, Italian and Spanish. Second thing, over the last 5 years, it seems to me that many Italians are kind of accustomed to accents like mine. And then there's a third thing I would like to say. We actually do not know how life originated on Earth, and that is because nobody was there during the transition between the inert state and the state of being alive. One always talks about the scientific method, but there are lots of scientific methods. And the way in which a synthetic chemist is different from the way a paleontologist or a cosmologist researches, or someone who does linguistics, evolutionary linguistics. Evolutionary biology is a historical discipline, and in this respect, we try and bring together evidence ranging from the possible composition of primitive Earth or possible relations in order to create a historical narrative. From this point of view, the study of the origin of life very much depends on the contributions of several scientific disciplines. In other words, what we try and do is to create a multidisciplinary and interdisciplinary research area. We know that forming a planet is very easy. We know that hydrogen is the most abundant element in the universe. At the beginning of the solar system, the primitive Earth had an atmosphere without oxygen, free oxygen, and there was lots of hydrogen. We also know that the kind of synthetical chemical reaction that is needed in this atmosphere is known. We try and analyze the composition of the Earth's atmosphere, meteorites, for example, to try and understand the chemical composition of the primordial broth of this kind of the primordial soup. And we know that actually there is just one molecule, and that there's the interaction. Everything is based on the interaction of several molecules. So we are aware of the importance of the RNA, which is some kind of a chemical buffer. And then we can compare from an IT viewpoint to try and understand how the first metabolic reactions took place. But all of these are assumptions. And what we try and do is to try and refine, to, in a way, break down into details what we do. The problem of the origin of life will always be an open problem. That will always be an open issue. So we can only but speculate. But we need to remember that speculations can take on several meanings. So, I mean, the word speculation, first of all, has to be related to its Latin meaning. So, looking at yourself into a mirror. Or, for example, that's the meaning of banks doing speculations. And then you also have scientific speculations, which is always a reference framework where chemistry, physics, astronomy gave their contribution. They provide a set. They provide a set of rules. And the more we do this, the more precise and detailed our narrative becomes. But still, it is an open narrative. Thank you. I would like to thank in particular my friends Tommaso Bellini, Tommaso Frassia, and Giuseppe Tanzella-Nitti for the possibility of addressing you today. I have already talked about my problem in expressing myself in Italian/Spanish. First thing I'd like to say is that when we talk about the origin of life, we start from an evolutionary point of view. And whenever you talk about evolution, the first reference person we have in mind is Charles Darwin with his masterpiece, The Origin of Life. And as you can see from this image, from this picture, the idea of evolution is the most powerful concept of the 19th century. And it is indeed one of the most brilliant, one of the most interesting ideas, legacies of enlightenment. The first person who talked about evolution is not a biologist, it is not even an astrologist, but rather Immanuel Kant, a philosopher who, at the end of the 18th century, put forward a really revolutionary idea. Today we know that Newton actually introduced the idea of the solar system as some kind of a cosmic watch in which you have equations that are symmetrical towards time, and thanks to that you can detect the position of a planet, of a moon, in this quite easily. And every day we can actually look at the outcome of this approach when we look at the way in which a satellite that is launched to another planet and that actually reaches that planet normally quite easily. So that's basically the outcome, the legacy of Newtonian physics. But Newton does not talk about the origin of this mechanic cosmic watch. Newton rather talks about a universe in which you have no origin and no end. Kant, conversely, did a really outstanding thing. He put forward a revolution. For the first time, he talked about the origin of the solar system as the result of the collapse of the condensation of a gas, of an interstellar gas cloud, which, due to gravity, then led to the origin of the sun and of the other planets. And for the first time in the history of scientific and philosophical thought, we had the idea of time that was introduced for the description of a natural system. Sometime later, we had the Marquis Laplace, who basically put this idea into mathematical formulas. Laplace actually wrote a publication containing equations and mathematical formulas of the time. He took reference on the ideas of Kant. He wrote a book, The Celestial Mechanics, and then gave this volume of his to Napoleon as a gift. Napoleon was a very smart and also sarcastic person. So he looked at the table of contents of the book and then told Laplace, actually, I do not see any reference to the word of God in your book. You rather talked about the mechanics of the sky. And Laplace replied, well, Your Majesty, God is an assumption that I did not need to write down my publication. This is really very important because this sort of started the process of secularization of our description of the universe. And at the same time, it also marked and showed that we have two possibilities which are not in contradiction. So on the one hand, we can have a mystic, religious way of analyzing the universe, and on the other hand, the possibility of a scientific vision. After Kant and after Laplace, many thinkers talked about the evolution of human beings. For example, Lamarck, in 1809, he wrote his book on physiology. That is to say, this book came out in the very same year in which Darwin was born. He became one of the masters, one of the teachers of Darwin. Then Sadi Carnot and Thomson talked about the increase of disorder in increase of entropy, and this also contributes to give this time dimension to a physical environment. Marx and Engels talked about economic production systems and their impact on social evolution. Renan talked about the evolution of religions. And Darwin is not, looking at all these names, you can easily understand that Darwin did not start the idea, but Darwin is rather the culmination, the end of this evolutionary way of thinking of the 19th century. Darwin did not talk in public about the origin of life. His work focuses on two main aspects. On the one hand, the idea that the past and present biologic diversity is the result of evolution. And Darwin put forward this idea of natural evolution as the mechanism that can explain biological diversity. He did not talk about the origin of life publicly. He was a little bit shy, so to say. But he, so to say, created a reference context within which it is indeed possible to analyze the origin of life. And then we had Ernst Haeckel, who came to Italy. He wrote about the unification of Italy, and he looked at Darwin's work and then decided for the first time to develop the idea of the so-called cosmic evolution. Haeckel, as a good German, read Kant, and drafted his book on the natural history of evolution, and actually stated that the solar system is the result of the condensation of a sun nebulosa. And as a matter of fact, the very same Earth originated like that. When the Earth is cold, you have water accumulating, and it is there that you have the surface of the Earth. And Haeckel did not understand very much about chemistry. And because of this, he promoted the idea of spontaneous generation and then explained this diversity that one can witness in his works. Like all German researchers, he had a very great, he was greatly a great influencer in the development of this kind of ideas in Imperial Russia and in Soviet Russia before. And it is in this context that Alexander Ivanovich Oparin, a young researcher who studied chemistry, biochemistry at the Imperial University in Moscow. And he proposed that what Haeckel called spontaneous generation can in fact be broken down in a number of steps. First of all, you have the formation of a reducing atmosphere, an atmosphere without free oxygen, because as there was no life, there was no photosynthesis, and therefore no oxygen, and therefore a reducing atmosphere because of the lack of oxygen. This is good because oxygen is very toxic for organic compounds. For example, if you cut a slice of apple and you can see that that slice of apple becomes dark, that's a reaction to the presence of oxygen. Oparin said that actually, as there was no oxygen, this led to the development of organic compounds. Actually, Oparin had a very strong training in this field. So he sort of took advantage of this knowledge of his to propose the idea of a primordial soup. And also because Oparin had a vision of genetics that referred to the times before Mendel, according to which life is the result of the interaction of several compounds. And at the time, the best physical and chemical model of the protoplasma, that's a substance that nobody talks about today. He proposed, for example, the idea of primordial cells. And according for Oparin, the first cells were anaerobic bacteria. And that is because nutrition is food. So all organic compounds present in the primitive environment were there. So if you look at these steps, you can see that there is no mention of DNA or nucleic acids. But that's understandable, because when Darwin proposed his description, Watson was already in primary school in the United States, and still there was nobody that was talking about double helix of the DNA. Still there was nobody who would talk about compounds that had the possibility of replicating. Oparin wrote his book in 1936, and that was the time of a very great, severe Stalinist repression. So his book was translated into English a couple of years later in 1938. But then in 1938, we already had the Second World War because there was already the civil war in Spain, and no researchers had the time to work on the origin of life, to do the most important things. Only after the Second World War, in the McCarthy period, it was not easy for anybody to work on evolution. But in those years, there was a young chemist, Stanley Miller, who decided to simulate the primitive primordial Earth and made an experiment under the supervision of Harold Dewey, an absolutely fantastic, great chemist. And Stanley Miller, with this experiment of his, he took ammonia, methane, hydrogen, as well as other compounds, and with electric charges, he showed that after a week you can have the synthesis of a number of compounds, including amino acids, which are also protein components. There was a small experiment. You can see on the left the image of Stanley Miller in the lab, and this, of course, changed the working conditions, because the upper flask is covered with asbestos, and nobody today uses asbestos. But it's interesting to see how young researchers would go to the lab. They would wear a tie, a white uniform. They would have cuffs, cuff rings, all well combed and dressed. And actually, if I compare actually them with my young students, well, that's quite a huge difference between the two. The most interesting thing, however, is that after a number of hours, Miller really observed the formation of life with no problems. So he witnessed the generation of organic compounds. In the same year in which Stanley Miller published the results of his experiments, we had the publication of the model of the DNA double helix. And as a matter of fact, the scientific results we had in 1953 were really fantastic. We had a scientific model of the molecular model and the Oparin's model. The publication of the double helix model actually forced every researcher to, in a way, look at the relationship with these results and the origin of life. And that is why it is important to look at the experiment that 7 years later my master, Jean Neuro, Catalan chemist, who showed that the cyanhydric acid so the cyanhydric acid undergoes a self-condensation, and then this is a very interesting reaction which can easily synthesize adenine, and this very, very rapidly. Some years later, other researchers in Mexico showed, at the Loyola Center, showed that if you take this kind of compound and expose this to sunlight, you can have the formation of adenine without problems. This experiment is very important because it shows that we showed the creation of amino acid for primitive Earth, but we could also explain the formation of nucleic acids starting from hydrogen cyanide. Of course, I'm not going to talk into the details about probiotic chemistry. That's really fascinating, but I'm not going prebiotic chemistry. But actually, there is no time to do that. But actually, how can we explain that there is the formation of organic acids on this? And we were lucky in this respect. In literary terms, this is a gift that comes from above, because the meteorites that fall on Earth can give us interesting insights on that. So NASA had prepared its labs to analyze the chemical analysis of these meteorites, and with these technical infrastructures, we then analyzed the Murchison meteorites that is exactly as old as the Earth, and you can see, when looking at the organic composition of the meteorite, you can see that it contains a lot of amino acids, carboxylic acids, purines, amines. So it has the very same composition to that of human beings. This is a clear indication. It doesn't show, but this is a clear indication of how we can imagine a primordial soup before the origin of life. And this in turn makes it possible for us to imagine primitive Earth as volcanic energy, as the fall of meteorites, of comets, of all of these elements that made it possible to form a large number of compounds like amino acids, nucleobases, etc. So basically, we can see that there's the formation of a primordial soup, but without a cook. So a soup that was formed by itself. So one can assume that God is an organic chemist. Okay, fine with me. But this is not an act of faith. This is not something that you can prove in a lab. We actually don't have a cosmic cook for the formation of a primordial soup for the Earth. The big problem that has concerned lots of researchers in this field was the following. How can it be possible to start from a primordial soup and obtain a molecule with DNA that has the capacity of replicating, that stores genetic information but doesn't have catalytic information? So what's the relation with that of proteins? And this has become a truly important, almost ideological problem. So what comes first, proteins or chemistry? And for 15 or 20 years, this has really become a very intensive debate, even a very hot debate between the various researchers groups working on this issue. It might indeed be possible that well before proteins and the DNA, you have RNA that has always been considered, so to say, the step-brother of molecular biology. So we thought RNA to be only a conveyor, to be only a messenger, but in fact, it turned out that this molecule has a very complex three-dimensional structure. Leslie Orgel and Francis Evie last century actually observed that this is a really interesting molecule. It is very symmetric, and that proteins are much more complex. And this structural complexity is actually what explains its catalytic properties. And they even observed that the RNA has this possibility of forming very complex spatial structures. And a really extraordinary thing was done by Orgel and Francis in biology. They proposed RNA to be a catalyst. This is very difficult. It's very difficult to make a prediction, to make an explanation in biology. It's not like Newtonian mechanics or organic chemistry. Crick and Orgel made this proposal, and after 20 years, this by chance, it turned out that the RNA has a catalyst property. It can act as a property, and actually they proved that the RNA can facilitate, it can promote reactions that can lead to the synthesis of RNA or the rupture, the break of RNA. This is really surprising because we've all been raised with the fact that it is proteins that can act as a catalyst. But today we know that we cannot explain biology without understanding the catalyst properties of an RNA. I once submitted these ideas to Crick, and actually he said, I have actually forgotten it. Actually, he had not forgotten that, but the fact is that the whole of biology was built on the fact that it is proteins that are the catalysts, and actually nobody, even if you are Professor Crick. Crick is a very outstanding, prestigious researcher, but nobody would believe that this was possible. So with this idea that the RNA has a catalyst property, we can say that the molecule of RNA contains genetic information, like the DNA, and that this is shown by lots of viruses, which also act as catalysts in terms of chemical reactions. So you can basically look in two different directions, like Janus, like the god of the Romans. You can watch in both directions. And as a matter of fact, the RNA is also the product of a chemical evolution. This does not imply that we think that all forms of life can be reduced down to RNA. Actually, it has been shown that the interaction between various molecules enables various reactions. There is a report on an experiment done by Saha et al. Showing how the molecules of RNA are self-organizing. And then there's this experiment of a friend of mine in the United States showing that a molecule of RNA can combine with green malachite, and if the RNA is within a liposome, it can then interact with the membrane of other molecules, and its binding possibilities increase to a very large extent. And this shows that Oparin proposal is really valid, namely the proposal that life does not depend on just one molecule, but that it is rather the interaction of several compounds. Today we can state that we have in a way promoted again the idea, the proposal of Oparin. We think that there are some compounds of primitive Earth that has come on meteorites and made it possible to have the formation of the primordial soup. Today we talk about the world of RNA, and we talk about the Darwinist evolution of a living being, of a living organism, of a population of living organisms made of RNA that then led to the creation of proteins and DNA. So this way, we have the possibility of forming a primordial soup. We do not know how to, in a way, send this kind of soup to the molecule of RNA, but the ribosome, namely this molecular sort of device inside each protein, this is a very strong evidence of the fact that the protein synthesis has originated in the RNA, and the RNA stabilizes genetic information. It is, of course, a product of biological evolution. And then we have this really fantastic presence of many different forms of diversity, of biodiversity. So this illustration is a very linear depiction of evolution, but it is important to point out that we do not know if it is exactly the way in which life has originated. It is very impossible. It is really impossible if this was exactly the evolutionary process that led to the origin of life. However, there is evidence, available evidence coming from physics, from chemistry, from paleontology, molecular biology, and from various very diverse areas of research are in line, are consistent with the possibility that this might have been the case. To conclude, there's one important thing to point out, is people make a lot of confusion. Evolution like progress. Actually, evolution is not necessarily an evolution and a progress to a more advanced, a higher form of life. This is not the case. There is no more advanced form of life. Actually, for example, form of life is much, in a way, simpler compared to bacteria, because bacteria have undergone a process in which you don't have formation of tissues. However, in bacteria, you have a metabolic activity that made it possible to provide the continuity of bacteria in this for over 4 million years. And we as human beings don't have this possibility. This idea is full of bias. I mean, you have the identification of a male, just to say that male human beings are more advanced, but that does not correspond to biological evidence. The wealth in biodiversity shows that you can have lots of areas to investigate. That's very important, because then you have the possibility of having forms of life in other planets. There is a book that you can easily find on the internet that George Basaglia, a researcher in the fields of philosophy and research, showing that we have a lot of prejudices when it comes to the development of technology today. And this is a prerequisite for the search of extraterrestrial life. And there's one thing that Lynn Margulis said, the search for extraterrestrial life is the cosmic life, is basically the research of the white Protestant group of researchers. So looking in this form of life in the universe is not the same. So we need to be very careful. We should not actually transfer to other planets this bias of ours. And then to end with, the search of intelligent forms of life in the universe has a number of characteristics that are similar to some researchers. Well, clearly, this is a consequence and also a reflection on the Cold War. That implies the possibility of a form of civilization that does not destroy, that is not self-destroying because of the atomic war. That's a utopian solution that does not take into account contemporary aspects. And actually, Frank Drake put forward this idea, and he once told on the occasion of a conference that we need to look for extraterrestrial forms of life because this way we can solve the problem of pollution in our planet and then look for eternal life. But that's, in my opinion, kind of a vague form of hope. That's of a non-authorized extension of the principle of mediocrity that can be found in Copernicus' work. That's the assumption of the fact that progressive technology is universal. Nobody today thinks that technology is always the solution for every problem we have. That's an anthropomorphic vision of cosmic evolution. And as Marx said, there are lots of religious implications of this idea. There are lots of people who say that so you may think that you're dealing with an extraterrestrial form of life coming from the world, but actually that's so to say a kind of vulgarized, low-level form of theory, just to say that you simply have to refer to an extraterrestrial form of life and that it appears on Earth, and that solves all of your problems. So my final close is very clear. When looking at an issue like the origin of life on the Earth and in the universe, we always lack a sense of intellectual humbleness. But this feeling of humbleness should always go hand in hand with our scientific curiosity.
Thank you very much indeed, Antonio, for this beautiful lecture, extremely interesting and clear. Well, I have now a question for Don Giuseppe Tanzella-Nitti. It's also a very general question, considering your background as a theologian and a scientist. How can you present the Christian theological thinking, considering life stemming from molecular phenomena that may develop also on other planets? Can sort of a Christian believer sort of accept the idea of a universe that is bustling with life? Well, sort of a Christian, a believer, has first of all to sort of believe in what has good grounds and in scientific terms. And so we talk about God as the living, the one who gives life, the one who is living. And so the prophets and the psalms are very clear on that. So God is different from idols because idols do not live, are not living being. Instead, the God of Israel is a living being. So what about the theory of the creation of the universe and the attitude towards that? Well, certainly, we actually don't know yet if life developed only on the earth or also elsewhere, but actually, I mean, this is just the reflection of the living entity by excellence. So I will try to elaborate on this with the presentation. I think that theology and Christian tradition, first of all, deal with the origin of life in the strongest sense of this term. So, in intentional terms, in terms of final purpose. So, why is it so that there is life on in the cosmos and on Earth? And this question is not very much different from another radical question that is the following: why do we have the universe? Why do we exist? Why each one of us exists. So when I will use the term origin, I will use it in this very powerful sense. So the origin of life in God, so the one who wanted life, alive in the universe, is compatible with different scenarios of beginning of life. So we may start from RNA, from the primordial soup. So we may have several beginning scenarios, biological or biochemical, and so on and so forth. When we talk about origin, we talk about an intention. So somebody wanted all that, and first of all, it had to donate the being of the world that reflects sort of God as living being. And so let's try to go down this pathway, and I have prepared some slides for this. Right, life in the cosmos between scientific research and Christian faith. Well, I don't want to tell you about a cook, but I will tell you about who thought about life since its origin. I'll try to do it in 3 steps and then a conclusion. So these 3 steps actually match some 3 questions. So does biological life comes from God? The appearance of life, does that respond to a project? Is our universe a universe bustling with life? So if we consider the biblical context, well, we have a rather explanation about the causality connection of God on life. So God is the living and loves life. So according to the Jewish Christian tradition, we see that life is the result of the clear and intentional will of God. It is exactly what God wants. It doesn't happen by accident. So it somehow sort of masters the mechanism that originates life, and the man and woman are created in front of God, by God, even though in the beginning their lives depend on the tangible and material elements. And I mean, this is quite clear in biblical text. The relationship with the Creator is different, is new, because they are personal beings faced with God. And God is the cause and the origin of life, and all the rest with matter and different shapes somehow contribute to originating life. So this is the major difference that I would like to underscore. We have the intentional beginning, and another one that is due to some physical, chemical, and biological causes. These are very, very famous extracts of the biblical sources. And those of you who already know these texts know that land is fertile, the waters are bustling, so there seems to be a certain, somehow relying on tangible elements. And when it comes to man and woman, so God created them, and so man became a living creature. So somehow it seems that God needs to look into man's eyes and to transmit something of his spirit. So if we talk about the theological perspective of the origin of life, that means trying to say something more. It goes beyond the first sort of living beings. And we have usually two narratives in the biblical text. We have Genesis 1 and Genesis 2. In the first chapter of Genesis, we have two perspectives, the theological perspective, but also the scientific perspective. We have a sort of a part devoted to the origin and another one to the beginning. So Genesis 1 uses the knowledge that was available at that time. Sometimes we think that the language of Genesis 1 is a sort of myth-related language that, was taken from the mythology of the peoples neighboring Israel. Actually, that is an example of an attempt of summarizing, trying to put together the scientific knowledge available at that time, trying to make that hand in hand with the faith and sort of the belief that everything had been created by God. So Genesis 2 has a more theological perspective and with a more allegorical language. So life, it's an attribute of God. It's something that God does not have. God is life. It's different from idols because it is living. It is alive. So life belongs to God. And God stands on the side of life. What is right and the just is connected to God with a connection that is stronger than death. And God gives life to everything through His Son that has come into this world to have abundant life. So the Trinity image let us understand to what extent the Father, from whom everything stems from, is really the origin. So the Trinity is marked by this privileged relationship to life. We have the three most frequent verbs of actions, especially in the Gospel, especially those about Jesus Christ of Nazareth. We have the verb therapein, so to heal, to treat. Jesus heals through His force, His sort of mastery and radical attitude, not because He's a physician. Let's see the theological implications in a scientific context. First of all, the creating action of God tends to sort of have personal beings in front of it. So the final goal of the creative act of God is to have interlocutors sharing His life in the highest sense. So the same way God is living. And the almightiness and the radical transcendence of the Creator fixes any articulation between the causality of God and the causality of the universe. So the secondary causes of physics, chemistry, biology, history. And so the Creator wants a universe for life. So this purpose is somehow the primary goal. So if we go back to sort of gastronomy as a metaphor, so the recipe is prior to the cook because it was designed. So the fact of talking about the finished thermodynamic cycle means that so God is life. So if we say that God is life, and if we say that, we somehow face a promise because life expresses itself like a promise. God is living, but life as we know it is a finished thermodynamic cycle. It's a finished and closed thermodynamic loop. So to have life, you need to have death. So life is self-transcendent. So in life lies a promise. The whole universe joins the Trinity-based ontology of life. God is alive because it's a trinity of individuals, of creatures. So everything is made thanks to love and tends to love. If the relational nature sort of underlies the ontology of life, even the biological life that is a reflection of God, relation needs to be very important. Life is a relationship. We talk about organisms, and life is a network of relations, and scientists do also know that there is an implication on the system biology. So we approach the living as an organism by itself. However, life and love in God's vision coincide, and the Trinity image keeps its meaning even within a cosmic framework. So if there was life beyond Earth, that would always be due to God as life, as living. But maybe our image of God as Trinity is too anthropomorphic. The idea of filiation and the spirit and so on. But where there is life, there is a generation. Where there is life, there is communion. And where there is life, there is the other. It is possible to have difference not only in the line of a generation, but also with respect to whom is in front of me, not generated by me. So the Trinity image of a God that it is a subject of inspiration and generation, so communion, if we think about it, it's something that is far from being anthropomorphic, because, well, it is quite meaningful. And the second step is about answering this question. Does the appearance of life respond to a specific project, yes or no? So, in the beginning, it was said that we are talking here about life, whether it is an inevitable phenomenon or a singular pathway. So, scientific research can provide a quantitative answer with equations, probabilities, and calculations that are very important and need to be made. But then there are also qualitative relations in life. Think about the choices made by a person when they decide to get married, or the relationship between a mother and a child. So here is not just about quantity, but also quality. When we talk about life, we can also talk about existential relations, which is the meaning of my life. So, and theology is mostly about this. And so the third aspect is the one that is most interesting for us, because we humans are interested into this, the answers about our own existence. So is that life is an inevitable phenomenon or a peculiar pathway? Well, actually, we are really asking ourselves something else. So when it comes to the world and its creation and its foundations, is there anybody? And does this anybody have something to tell me? And do I have some value in the eyes of this somebody? So these are the key existence-related questions. So theology gives answers to these questions. But this does not depend on how the question is asked. So there are several possible scenarios that generated life on our planet. And maybe in the future we will discover that life generated also on other planets. So we have a created universe tending towards life because this is the final purpose plan of a creator. And this idea is compatible both with the physical cosmos, where life is the result of a unique process that cannot be repeated, but it is also compatible with the idea and the image of a universe bustling with life. So both hypotheses, both speculations, actually the only two possible ones, the first one that we are alone and the second one that we are not alone, well, may seem both rather worrying, and I think that actually they're both extremely intriguing and fascinating and charming. We do not know yet which one is the true one. Maybe we will never ever get to know this because we will never be able to investigate our universe deeply enough to have a sort of answer. We can see signs of life, but the fact that we do not see signs of life cannot sort of let us state that there is no life somewhere else. So we have ontogenesis, and this is a vision. This is compatible with any evolutionary description of life, morphogenesis, including its beginning, abiogenesis. By the way, when it comes to medieval theology, scientific knowledge, the scientific knowledge that we have today was not available yet, there was no problem in admitting the so-called spontaneous generation. There are some St. Thomas sort of writings, and the St. Thomas talks about spontaneous generation as something that was taken for granted. Energy would come from the sun, the soil had the potential. So, life in its most basic expressions was the result of a spontaneous generation. Of course, it was not a sort of hypothesis that could make St. Thomas or Bonaventura worry. And the personal being, and I want really to emphasize this, owns some specific expressions like freedom and rationality that do not seem to result from Darwin-oriented evolutionary mechanisms, so that they operate only through genetic mutations and natural selection. Instead, the contemporary evolutionary sort of theories tell us that these are things that are related to our cultural evolution. So it does not depend from a genetic evolution, but actually somehow it determines that. I decided to devote a slide to the anthropic principle, that is, a set of scientific results that underline to what extent life was possible on our planet, and they're very delicate and perfectly in line with some chemical and physical constant elements that are the same that are present in our universe. Sometimes we talk about the anthropic principle as if it was the sort of confirmation of a project. Others talked about that in sort of tangible, deterministic terms. I would like simply to clarify some concepts because I think there is a bit of confusion on this. The first concept is that the so-called anthropic principle, so the existence of such delicate settings, say, of compatibility between biological life and sort of God's conditions are enough, are necessary conditions, but not enough, because So they could not be there, but actually life could not be present, because in order to have a good mark at an examination, I have to study. But sometimes it's not enough, because maybe the teacher can ask strange things, and maybe I can be a bit sick, so maybe you won't get the best mark. And the same applies to biotic conditions of the anthropic principle. So some conditions are necessary, but they do not determine by themselves life. The anthropic principle does not sort of present life as an inevitable phenomenon, but only compatible with the sort of original structure of cosmos. And well, we must remember that some elements are not result of selection, but they were determined from the beginning. A deterministic interpretation of the anthropic principle would remain an SAP, a strong anthropic principle, so, and not a weak anthropic principle. The anthropic principle is not a demonstration neither in favor nor against the idea of an intentional project in nature, because it's an argument at the level of efficient causes. So these cannot have an impact on the level of the causes of the being, and most of all on the intentional causes level. The third and last step is this one. What about our universe bustling with life? So let's see which can be the theological perspective of dissemination of life in the cosmos. First of all, I think that this question about life and life within the cosmos has some sort of religious references. Let's talk about Paul Davies. And we know that the attraction element seemed to be in ET, that by contacting superior beings coming from the sky, we could have access to privileged knowledge. And so the extension of our horizons can get us closer to God. ET research can be seen as the research for sort of some sort of religious elements, but also some scientific elements. As it's like if we were looking for answers to extraordinary, very important problems, but actually we can't. So we hope and wait for somebody coming from outside, from an anthropological horizon that is out of ours, and give us these answers. So this idea is very close to the idea of the Jewish Christian theology. It's God that reveals himself to man, because he's telling us his design, his project, and he comes to us at the same level as man, as human being, so that we can all understand without misunderstandings, as St. Thomas said, so without any risk of misunderstandings or mistakes. So theology develops a wide number of questions about life and the cosmos. So many of them are legitimate, and I think that the science can ask questions to theology. So the faith into God, the Creator, and into its Verb made flesh is compliant with the hypothesis of smart life within a cosmological context. I think that the answer to this well-formulated question is yes, it is consistent. What is the relation between extraterrestrial life, if existent, if present, with the revelation of God as life and source of life. Well, that will be his reflection, which should be the relationship between intelligent extraterrestrial life with the revelation of God as a final spiritual goal of intelligent life in the cosmos. Well, some authors have already tried to answer this question, but then there are some questions that are not consistent because they are not epistemologically well formulated. I'll try to give you some examples. So if we were to explain if extraterrestrial intelligent life has or does not have an original sin, well, it can't be answered, and you can't be forced to give answers if you have no information. Or also if God should or should not embody and be killed on a cross on other planets. Well, it's not possible to answer. Or the presence of extraterrestrial life on other planets different from Earth is confirmed or debunked from biblical writings. You know that there is everything out there. Well, these speculations are sort of totally nonsensical. There are no grounds. So if theology renounces such questions, it's not because they are too difficult to answer, but simply because these questions are formulated in a way that make it impossible to answer, because if you don't have specific suitable information, you cannot answer. And the Christian God is not a Platonic God. You cannot infer everything. And the Christian God is most of all life and freedom. It's not a Platonic God. So we cannot deduct some specific things because they belong to the freedom of God and his salvific plans. So let's see some theological perspectives about life in cosmos. So there are no prejudicial arguments against the presence of extraterrestrial life, ET life. The uniqueness of human being cannot be defined in the beginning as anti-scientific or naive. Well, in the lack of other different data, it's the only thing that we can say. And the Jewish and Christian tradition, let's not forget it, preaches the faith within the existence of angels. In other words, the sense of the universe is not entirely and only based on the relationship between God and man, but it opens up to other creatures. And even if those creatures depend on God, they can sort of have a different salvation economy from human beings. Well, we know very little on angels, and well, it's even more difficult to know about other creatures. And the Trinity image keeps its consistency also within a cosmic context where other forms of ET life could exist. The Trinity does not have no local elements. And we have also the connection with the generation process that is shared by any living being. And we have the idea of love as gift. And again, this is related to the idea of a free life and a self-aware life. What can we say about the cosmic capital role of Jesus Christ? Well, as far as we are concerned, well, this has no local meaning, so it's not anthropocentric. And we have a salvific role that is not just local, not at all. So Christ plays a key role also when it comes to angels and can be considered as a revelation of its central role in respect to any other creature. We know that we cannot reduce the importance of the embodiment of God's verb onto that. Would be sort of a limitation. So it's a Christocentric importance. It's not geocentrical and not anthropocentric. So a divine verb being embodied and made of flesh is the center of the cosmos because it turned into a creature. And this transformation into a creature is key to any creature because God took the form of an element of the created universe, and that went beyond. So any sort of specific dimension of space and time and matter. So he decided also to accept death, and the resurrected body showed the sort of fact that the promise was kept and fully implemented. So this is a promise that has to do with the whole universe. So the promise there is not just for our life, but for the whole universe. The redemption from sin, something we get to know in human history, the death of Christ on the cross also refers to the aware acceptation of being finite. So the fact that we are going to die, and even Jesus' resurrection is then meaningful to any creature. The idea of a future dialogue seems seems to be hard. I mean, we talk more about detect and not dialogue, but still, I think that it would be great to see a common origin and the possibility to better understand the relations with the whole universe. Such an encounter, about dialogue, well, may have a religious dimension with ET life. There is a very widespread idea that the relationship with intelligent life would set free the Homo sapiens from a childish religious phase. Is very naive. So are we waiting for big answers from somewhere else? That would be naive. The vast majority of our key fundamental questions would keep their full meaning. The suffering of the innocents, pain, death, the hope to resurrect. All this is strictly related to creatures, to being creatures, and not specifically to being human being. And a last word on ET life. And the last word on that does not entrust with theology, but with science. The existence of life, and in particular intelligent life on planets that are different from Earth, is not excluded nor requested by any theological argument. So humankind and theology just have to wait. I'll stop there, and I thank you very much.
Grazie, Don Giuseppe.
Thank you, Don Giuseppe. I'd just like to spend a couple of words for the last part of this meeting to ask a couple of questions to our two guests. My questions are a little bit more personal. I would like to ask Antonio about the importance on researching into the origin of life. What impact do you think this can have on the concept that we have on life, on the origin of life? Because when we are asked when we're asked such a question, that means that there is deep curiosity. So based on your experience, what's the impact of researching, of searching for the origin of life? Actually, this is no easy issue, but there are two things to point out. You can pursue the philosophical aspect. There's the possibility to reflect upon the origin of life. This was said by Aristotle. He said that if you want to understand something, you have to understand how that something originated. So understanding the origin of life is very important, especially today, given the latest developments on the origin of life. I think it is important to search in this field because it enables if not the precise definition of the origin of life, at least to have a clear classification of what we mean by life. Contemporary societies today are characterized by debates on abortion, on synthetic life, on euthanasia. In other words, topics that are very close to life. When searching for the origin of life, one tries to understand and explain the transition between what is not alive and what is alive. So we have come to a point in which no theological, economic, or scientific system can give solution to this problem. So in scientific terms, I believe that if we try and understand this extraordinary diversity, both past and present of life, then we must understand its origin. In other words, what are the properties of a system which is not only chemical, not only physical, a biological system that has such a great potential, not in Aristotle terms, but rather in terms of development. What's its potential to transform the planet? So the Earth is very peculiar in the solar system because it is a planet of life. I don't think there are forms of life on Mars or on any other planet of the solar system. But if you look at the Earth, it is impossible to understand the evolution of the atmosphere, its composition, or the composition of Earth, of the waters in the Earth, or of the sediments of the Earth without the participation of the biosphere. So in this respect, I believe that to understand the whole system, we really lack a big definition of what the origin of life is all about. And a final reply is requested also on the part of Don Giuseppe. In these times, science and technology appear to have launched new challenges to the concept of the origin of life and to many other contexts as well. As a priest and as a theologist, what are your concerns in this very challenging moment, challenging on the very same concept of life? I think the challenges we're faced with are twofold. When it comes to challenges in terms of knowledge, well, I wouldn't have so many concerns. Theology and faith, which is much more than theology, needs knowledge, any form of knowledge. So anything that can enhance our knowledge, scientific knowledge background, contributes to a more responsible faith and to a more mature theology. So from the point of view of knowledge, this challenge is not a competition. There is a sentence by Tommaso Campanella in his apology for Galileo, maybe he was being kind of polemic there. But actually, Tommaso Campanelli once said, and I quote, "Those who forbids us Christians to cultivate science actually forbids us to be Christians." From an ethical viewpoint, instead, it seems to me that we are indeed confronted with a challenge in which believers shouldn't feel alone. I mean, this challenge is a challenge for man because science and technology are at the service of human life, and that not because there is a transcendental faith that states that man is at the image of God, but because for all believers, human beings are the most precious assets that we have. So there is some kind of a precautionary principle there. Human beings are the most precious, most valuable asset we have, and because of that, ever since their conception up to their natural death, human life must be seen as a resource, as an asset with an aim, and not as a means. And here you might identify, you can identify concerns when it comes to some technological applications. Many of the problems that are caused when it comes to bioethics, biotechnologies, many of these problems are more, in a way, dictated by economic reasons or profit-related reasons, much more by these aspects than by the need for knowledge. Thank you very much. I would like to thank our guests once again. I would like to thank them on behalf of the meeting organization and the people of the Rimini meeting. The issue of the origin of life in the universe are topics that really touch us. We've always tried to deal with scientific topics here at the meeting which are of great concern, and certainly this is one of these topics. As you have probably seen also during this encounter, looking at these topics through scientific investigation, you can come to some answers, but not a clear-cut answer, not to a final answer. Actually, you can come to develop a more precise, a clearer and refined question. Primordial life is a molecular process. Maybe it is a deeply rooted issue, given the way in which the Earth is done. So looking at the origin of life helps us understand our continuity with the entire universe. At the same time, however, it also gives us a strong feeling of discontinuity, because life, especially when you get passionate about the fact that about the origin of life, has to deal with you feeling alive, and that appears to be so far away from this assembly of RNA, so that we feel continuity and discontinuity at the same time. As Don Giuseppe said, talking about the origin of life means doing something more than talking about the origin of the first human beings. So you have a plurality of levels, because of which this discontinuity between our experience of as human beings and primordial life, or the biological material aspect of life, is something that we continue questioning, and that's a source of concern and uneasiness for us. That's concern that brings a pressing question with itself. As Don Giuseppe said, is there anyone in the foundation of the world? To quote what Don Giuseppe said. I mean, looking at scientific issues with such a strong existential echo, I think that this kind of questions are always inevitable. And I would like to draw to a close by adding a couple of household announcements which are very important for the Rimini meeting. First of all, tomorrow, Friday, on the 24th of August, in the A3 room, we have Mohamed Abdam Khalisa, the General Secretary of the Muslim League. That's the most important Muslim league, Arab league worldwide. That's a really exceptional event because the meeting hosts the first contribution in Italy of Secretary General Alissa. Second household announcement, that's an appeal for you to help the meeting also in economic terms. The Rimini meeting is something unique. That's a unique event because it is for free. And it is for free because it is the result of a collective effort. So we are kindly asking you all to contribute and to donate. There are the Dona Ora stands. They are marked by a red heart. And actually the meeting is kindly asking you to donate your contribution in these desks, in these dedicated desks. Once again, thank you very much to our dear guests, and I would like to thank all participants for being here. Thank you very much.